Sketch the graph cos x from 0 to 360. Sin x looks like an S. Cos x, if you turn it on its side, looks like a C. So we'll draw the graph. To get the C, it goes down through 90, across to 180, that's its minimum point. By 270 it's back to 0, and then by 360 it's back up where it's supposed to be. That is not full marks, because you need to tell the examiner about this axis. Cos graph goes from 1 to -1 unless it's been stretched. Part B of the question. Using my graph, cos 30 is cos of something else. Well, cos 30 is here. It's got a distance of 30. If I keep thinking across this graph, there is another number that would give me the same answer. And I'm thinking, because of the palindromic nature of this graph, that distance there is going to be the same as that distance there. So if I start at 360 and go backwards 30 degrees, gives me an answer of 330 degrees. Transformation of graphs. On this graph, function of x is shown on both the grids. On this one, draw the graph to function of x plus 1. I always like to, well, I can't do two things at once, so I'll deal with the plus 1 first. The plus 1 is inside. When you're inside, you're not very happy. It's not doing what you expect. You're shaking your head, going left and right. You'd expect a plus 1 to go right, but it doesn't do what you expect. It actually goes left 1. So I'll just sketch in what that graph would look like. It's not a full and final correct answer, but it helps me to see where the graph's going. The graph has moved left 1. I'll deal with the 2 next. You could, of course, have dealt with the 2 first. The 2 is outside, and whenever things are outside, I'm jumping up and down in joy, and it's doing exactly what I expect. It's making it twice as tall. That was at a height of 1, so I'm going to draw this bit at a height of 2. This next vertex here is interesting. That had a vertex of 3. Double 3 goes up to 6. So the whole graph is getting twice as tall. It comes back down to 1 over here, so I'll double that height and draw in that bit. Should really be using a ruler in the exam for that. And to finish off the question, we've got this little bit here to finish off. I would just show the examiner it's the solid one, because I have written something there and they might not know which one to mark. Part B. On the grid below, draw the graph y equals minus function of half x. Again, it doesn't matter whether we deal with the minus or the half first. Let's deal with the half. It's inside. When things are inside, I'm not happy. It's not doing what I expect. I'd expect that to halve. The opposite of halving, doubling. That 3 along the x-axis doubles to 6. The 2 would double to 4. So it looks like my graph is doing this so far. It doesn't matter how much you stretch the point 0, it will stay at point 0. And again, this minus 2 will double to minus 4. And the minus 3 will go to minus 6. Just get rid of that bit. So my graph has doubled in size. It's doubled in width because the half is inside. Then we've got the minus to deal with. The minus is outside. When we're outside, jumping up and down in joy, doing exactly what we'd expect. If you imagine a positive x squared graph, a nice smiley face, it becomes very unhappy. It reflects in the x-axis. So I've got to now reflect this dotted graph in the x-axis. It would look like 3 would go to minus 3. to -1 there, and finishing off the graph like that. Again, I'll tell the examiner, mark this please. I can't do these questions without sketching the questions twice.